Hello, ladies and gents. We're talking about acids and bases. And this time we are going to talk about where do the names come from for acids and bases? How do chemists name them? What rules apply to naming acids and bases? We're going to begin with naming bases. And bases are actually the simpler of the two to name. Now, when you're naming bases, most common bases are named using the rules that we have used in the past for naming polyatomic compounds. To refresh our memories, the way you name these is the name of the positive ion followed by the name of the negative ion, and you never change the name of polyatomics. So let's go through a couple of these. Sodium hydroxide, which is commonly known as Li. Sodium is a group 1 metal, which means its most common ion is +1. And hydroxide is a polyatomic. There's hydroxide right there. It has a most common ion of -1, and nature puts those together so that it's going to have a net charge of 0. So you have 1 sodium, 1 hydroxide, NaOH. Magnesium hydroxide is a group 2 metal, and group 2, the most common ion, is +2. Magnesium with +2. Hydroxide again, OH, and remember that is part of the definition, the Arenhus definition of a base, is that it produces hydroxides in a solution or releases hydroxides. So we have 2 magnesiums, 1 hydroxide, not the same. We crisscross, this goes there, that goes there, and we end up with Mg2OH and Mg parentheses 2, and the 2 comes from that 2 that slid down. Let's do one of these from scratch. Potassium is a group 1 metal, so K +1. Hydroxide is an OH -1, one of each. Nature puts things together to have a net charge of 0, and KOH. All right, what I'd like to have you do is try these. Hit pause, take 1 minute, go through these, see if you still recall how to do this. Then we're going to go through these together. Okay, here we go. Ammonium. Ammonium is a polyatomic, and ammonium is NH4 positive. Hydroxide is the OH negative. If you've got a +1, -1, nature's going to put one of each together. So NH4OH is our formula for ammonium hydroxide. Sodium bicarbonate. Sodium is group 1. Most common ion is +1. So I'm going to have a sodium +1. Bicarbonate, let's see, bicarbonate's right there. HCO3, and it's -1. Again, nature's going to then just require 1 of each to have an ionic compound with a net charge of 0. Calcium carbonate. Calcium is a group 2 metal, and that means calcium +2, most common ion. Carbonate, let's find it, is right here. Carbonate is CO3 2-. Nature wants a net charge of 0, so it's going to take 1 of each, CaCO3, calcium carbonate. It's been a while since we've done those, but hopefully you look at that and went, oh yeah, I've done that. I remember how to do that. But that's how, and you can go from the name of a base back to the equation. Now, naming acids, there's a couple different kinds of acids. First, we're going to start talking with binary acids. Bi means 2, like bicycle. If you have a binary acid, this is an acid made of hydrogen plus 1 other element. And when you name these, the prefix is hydro. Prefix means the bit in the beginning. So the prefix is hydro, and the suffix is the name of the other element followed by -ic. So let's do this. So hydrogen and chlorine, the prefix is hydro, so hydro. And then chlorine gets changed to chloric. So this is hydrochloric acid. Hydrochloric acid. This is H2S. This is an acid, so hydro is the prefix. And we know to name it this way because it's binary. It only contains 2 elements. Sulfur becomes sulfic. Sulfic? Yeah, I think so. Hydrosulfic acid. Okay, hit pause. Try the next two. Try these. All right, here we go. Hydrofluoric. And again, I know it's tricky to know exactly where do you cut the word off and put the ick on. That just comes with experience and your ear gets used to it. Hydrofluoric acid. This one is hydrobromic acid. So that's how you name binary acids, acids made of just two elements, hydrogen and one other thing. Because remember, the Arenhus definition of an acid means that it supplies hydrogen in solution. Now, many acids contain oxygen. Not all of them, but many do. The French chemist Antoine Lavoisier, here's a picture of Antoine Lavoisier and his wife. Lavoisier thought that oxygen was in all acids, and the name oxygen actually comes from a Latin and it means acid producer. And he named oxygen oxygen because he thought that oxygen made acids. He was wrong, but sometimes a name sticks. So it can help you realize that oxygen is in many, but not all acids. So when we're naming acids that contain both hydrogen and oxygen, here's how you do this. The first name is based on the other element. The suffix depends on the number of oxygens. If there are two kinds, the one with more oxygen ends in ic, the one with fewer oxygens ends in us. Just like when we were dealing with transition metals, the big one is the icky one. All right, so let's go through a couple of these. This is hydrogen and nitrogen and oxygen 3. So how do we name this beast? Okay, the first name is based on the other element, not hydrogen and oxygen. So this is based on nitrogen. So this is going to be Now is this nitro, and then there's another one that's got nitrogen in it, and this is going to be nit. One of them is ic, one is us. This one has more oxygens, this one has less. So this is going to be nitrous acid. Oops, I said that so wrong. This is going to be nitric acid. The big one's the icky one. Nitric acid, and this is nitrous acid. Okay, nitric acid, nitrous acid. Hydrogen, oxygen, and sulfur. Hydrogen, oxygen, and sulfur. This is the big one. So sulfuric, because this is the big one, sulfuric acid, and this is going to be sulfurous acid. Okay. Weird stuff, but this is how they are named. Sulfuric, sulfurous, nitric, nitrous. This is chlorine, so this is going to be chlor, one's ick, one's us. This big one's the icky one, chloric acid, and one is going to be chlorous acid. Can't spell acid today, okay? So chloric acid, chlorous acid. Oxygen is so important in acids that you can have acids that contain a whole variety of different numbers of oxygens, but chemists like to change the names when the oxygen number changes. If it contains even more oxygens, they add the prefix per. As a Greek and Latin prefix, per means extends and continues on. So for example, permanent means lasts through time. It goes on and on and on and on. So it means more. So chloric, chlorous, chloric is the big icky one, chlorous is the smaller one. But if it continues on to have even more, it's the perchloric. So this is oxygen 4. Even more oxygen, you add the prefix per. Hypo is a word that means below, hence the term hypodermic. Dermic means skin. Dermic means skin. A hypodermic needle goes below the skin, and it actually dispenses that medication within or under the skin. So hypo means less than. It goes below the other quantities of oxygen. So hypochlorous acid is chlorous but one less oxygen, HClO. There's actually logic to the names of acids, but you have to kind of know the rules. All right, that will do for naming acids and bases. We'll see you next time. Bye-bye.